Hey everyone! If you've ever found yourself wondering how coding assistants actually navigate massive code bases without losing their minds, or, if you're actively gearing up to ace the Claude Certified Architect exam, you are exactly where you need to be. We're going to master the 6 core built-in tools that Claude uses straight out of the box. By the end of this, you'll know exactly how to direct your AI agent without wasting a single precious context token.
Okay, let's dive into this. Here's a quick look at our roadmap. 1. The built-in Claude toolkit. 2. Finders, Grep versus Glob. 3. Loaders and token limits. 4. Modifiers, write versus edit. 5. Incremental exploration pattern. And finally, 6. Real-world developer productivity.
Moving into Section 2, Finders, Grep versus Glob.
Okay, let's establish what we're actually working with when it comes to finding things. Honestly, confusing these next 2 tools is a classic, and highly testable mistake on the exam, so we're going to clear it up right now. I absolutely love this analogy from the source material. Imagine your entire codebase is a massive physical filing cabinet. Grep? Well, Grep is the person who physically opens up each drawer, pulls out the folders, and reads through every single document looking for a specific word or pattern. Glob, on the other hand, is the person who just looks at the labels on the outside of the folders in that cabinet to find ones that match a certain naming pattern. Glob literally never opens the files.
That filing cabinet analogy brilliantly captures the operational difference between these 2 tools. Grep is your content detective. It really doesn't care what the file is named. It cares exclusively about the text actually written inside of it. Glob, conversely, is your file path hunter. It completely ignores the actual code or text inside the file and searches entirely based on the file's name and its directory path. Let's rapidly run through a few scenarios to really cement this mental model. Say you need to find all the .py Python files in a source folder, or maybe every single test file in a project. You use Glob. Why? Because you're hunting for a naming pattern or a specific file extension. But if you need to find every file that imports React, or literally everywhere the function process_refund is called, you absolutely must use Grep. You're hunting for the actual code living inside those files. Seriously, mixing these 2 up is a super quick way to lose points on a certification test.
Moving right along to Section 3, Loaders and Token Limits.
So once you've successfully found a file, how do you actually look at it? Well, that's where our loader tool, read, comes into play. It pulls the full contents of a target file directly into Claude's context. But listen up, because here is a massive warning sign: the bulk reading anti-pattern. This is arguably the single fastest way to completely destroy your agent's capability. If an agent is instructed to blindly read dozens of files right at the start of a task, it just burns through your entire context window, the AI's working memory, before it's done any actual reasoning or problem solving whatsoever.
So the absolutely crucial takeaway here is this: do not bulk read large code bases. If you're sitting for the certification exam and a multiple choice question suggests reading all files first as a viable solution to understanding a code base, it is almost certainly a trap. It's the wrong answer. Your agent's quality will degrade so incredibly fast as that context fills up with irrelevant information.
All right, let's shift gears to Section 4, Modifiers, write versus edit.
Once we've found and read our code, how do we tell the AI to actually go ahead and make changes? We use write and edit, and these 2 tools serve entirely different purposes. Write is essentially a brute force, atomic operation. It either creates a brand new file from scratch, or it completely overwrites an existing one. Basically, whatever you pass to the write tool is exactly what ends up on the disk, completely erasing whatever was there before. Edit, however, is a lot more nuanced. It allows for targeted, surgical modifications to specific sections of a file without rewriting the whole thing. Think of it like a super elegant find and replace. If you've got a massive 500-line file and you just need to tweak 3 lines, edit is exactly the tool you want to use to save those precious tokens.
But there is a very specific catch here. And trust me, this is highly testable exam material. Edit requires the old string, as in the exact text you want to replace, to be 100% unique within that file. If the exact text you're trying to edit appears more than once, the edit tool is going to fail because it simply doesn't know which occurrence you actually want to replace. A fantastic pro tip from the source is to provide a longer, much more specific string of surrounding code just to guarantee your target block is completely unique.
So what happens when edit does fail? Because your text just isn't unique enough. You use this canonical fallback pattern.
First, you've got to trade efficiency for reliability. You use read to load the full file into context. Second, the agent modifies the code right there in its own memory. And third, you use the write tool to completely overwrite the old file with the newly updated one. It's definitely less elegant than a surgical edit, but hey, it works every single time.
Okay, moving to Section 5, Incremental Exploration Pattern.
How do we actually put all these tools together to explore a code base safely? We avoid that nasty bulk reading trap by using a cyclical logic. First, you grep to search for a specific entry point or function name. Second, based on exactly what grep found, you read that specific file. Third, you trace the logic inside that file to find your next dependency. And fourth, you grep again for that new dependency. You see the loop here? Each grep call informs the next read operation. You build up your understanding incrementally, only loading the files that are strictly relevant, which keeps your context window incredibly efficient.
And finally, Section 6, Real-World Developer Productivity. Let's bring this whole thing together to see an AI coding assistant in action. The entire workflow essentially breaks down into 4 phases. Phase 1 is discovery, where you use Glob to map out the folder architecture. Phase 2 is understanding, using grep to pinpoint functions and read to load them into memory. Phase 3 is creation, using write to generate totally new boilerplate code from scratch. And finally, fixing, using edit to surgically patch legacy issues. And oh, of course, there's bash, which is basically just your escape hatch for executing standard terminal shell commands, like running tests or installing packages. As you can see, every single tool has a very clear, dedicated lane.
Which brings us to our final thought for today. The overarching lesson from this explainer is that just throwing entire code bases into an AI's context window isn't just lazy, it is actively destructive to the agent's reasoning capabilities. By mastering these 6 tools, grep, glob, read, write, edit, and bash, you force your agent to be methodical, efficient, and precise. So, knowing the immense cost of a wasted context window, how will you optimize the tool sequence for your next AI agent? Keep that in mind as you build, and for sure as you sit for your architect exams.